All right, in this short video, I'm going to help you try to figure out what value of Hardy-Weinberg is being given. So I want to kind of explain the two frequencies, the genotype frequency and allele frequency. You have this in notes if you need it, so you can refer to it as you're doing your problems. But I'm going to go ahead and just get started. So there are two frequencies that you can be given with Hardy-Weinberg. You can be given a genotype frequency, or you can be given an allele frequency. And so your job is basically to try to determine which of these frequencies you're being given, and that is challenging. And so first of all, let's talk about what is a genotype frequency. Genotype frequency is what percent of your population has that particular genotype. And so with your genotype frequency, you're looking at organisms, you're looking at your population, and you're saying, hey, of this population, maybe 17% have the genotype big A, or homozygous dominant. And so you're kind of looking at the people and what they actually have in terms of their genotype. Now, in terms of the Hardy-Weinberg variables, since a genotype has two letters, all of the variables have twos in them. So P squared, that's going to be the homozygous dominant. 2PQ, see that 2 in there, and there's two different letters. That's going to be our heterozygous, or sometimes they're called carriers. And lastly, Q squared, that's going to be my recessive. So homozygous recessive, or little a is Q squared. So look for keywords like population, or perhaps look for organisms, because that percentage should be referring to the organisms themselves, like some percent of the organisms or some percent of the population. And then one other way that you can be given one of these values is if they give you the recessive trait. If they give you the recessive trait, you know that those people who have the recessive trait must also have the recessive genotype. And if they're giving you the frequency of the recessive trait, they're giving you the frequency of the recessive genotype, or the percent in the population of that genotype. So technically they've given you Q squared. So this is a very, very helpful piece of information. Now, if they give you the dominant trait isn't as helpful, because the people in the population who have the dominant trait are homozygous dominant and heterozygous. So, other words, if they tell you that, 80% of the population is dominant, that's P squared plus 2PQ. And that is nothing that we can use, because I need the individual values, not them added together. I don't know how to break that apart. There's no way to solve for P or Q given that information. So the dominant trait, to be honest with you, isn't all that helpful, but the recessive trait really is a key one. They will oftentimes give you that recessive trait or the recessive phenotype, and you need to know that that is giving you Q squared. There's also what we call the allele frequency. The allele frequency isn't looking at the population. Instead, it's looking at our gene pool, and it's saying, in my gene pool, with all these genes in here, what percent are either dominant or what percent are recessive within that gene pool. The percent dominant, that's going to be given P. The percent recessive, that's going to be given Q. And so we're not looking at organisms, we're not looking at people, we're looking at the gene pool for the population. They will always say the word gene frequency or the word allele frequency, or simply be talking about a gene or an allele. So those are your key terms right there. If they don't say that, then you're probably looking at a P squared or a Q squared value. If they say the gene that causes something or the allele that causes something, then you're looking at your P and Q. Remember, P dominant, Q recessive. And so this is the basic information that you need to understand in order to be able to look at a problem and say, are they giving me one of these genotype values, or they give me one of these allele values? And once you know where to start, then you can solve the rest of the problems and verify that we are in equilibrium. Let me know if you have any more questions or you need any help with this.